So I've been meaning to make this recording for a long time. I graduated in physics quite some time ago, and I've been a practicing engineer ever since, but I am very practical. And I've thought a lot about a lot of things, and the whole issue of quantum mechanics and gravity has been waiting on my mind. I'm not going to offer you a new theory of gravity. I'm not that crackpot. But I'm going to try to reinterpret the theory of gravity in a sensible way that makes sense. So if you remember Einstein's thought experiment about the elevator, if you're sitting on the earth in an elevator and you feel the force of gravity pulling you down, and then all of a sudden that elevator is transported to outer space and there's a big rocket underneath you accelerating you to the velocity for an acceleration of 1g, you in the elevator can't tell the difference. You cannot tell the difference. There is no method, no possible way, no tools, no measurement that you can tell the difference between sitting on the earth, feeling the pull of gravity with 1g, or out in outer space with a rocket pushing you at 1g. So here you are. Are these two things equivalent? My thinking is yes, but that poses very complicated issues because they're totally different. If you think about gravitons on the surface of the Earth, you think gravitons are pulling you down. That's the force field that modern physics tries to impose upon you. And if you're in outer space, is the rocket making gravitons? It seems absurd. No, the rocket is not making gravitons any more than when you step on the accelerator in your car and feel a force of acceleration, that your car engine is making gravitons. So we're left with the quandary. Are the two accelerations in the elevator equivalent? My assertion is yes, so certainly they are. If any other, you'd have to really bend credulity to think that somehow the two are being caused by different means but with the same result. So what does that mean for us? It means that, first of all, that the macro universe, governed by Einstein's general theory, is not quantum mechanics. Quantum mechanics does not govern the interactions of bodies in space through gravity. So we have a macro universe ruled by gravity, and we have a micro universe ruled by quantum mechanics. They're both very substantially verified. So I think that is the case. And what happens? Let's go back to the Schoedinger cat. Let's back up. I assert that the macro universe doesn't care what quantum mechanics does until it makes a real effect in the macro universe. So, and when something real happens in the macro universe is quite satisfied with it and goes rolling on. So the Schrödinger cat, if we have a piece of radioactive material in a box with a cat and a death machine, so when the radioactive material produces a gamma ray or something, it kills the cat. Well, if you didn't have a cat in there, the gamma ray would go out and hit the wall of the box, and that is a material effect in the universe. So the universe is happy because the gamma ray may hit an atom in the wall of the box, and the atom recoils, and that's a real thing. If you put a Geiger counter and a cat in there, if the gamma ray hits the counter and kills the cat, that's a real thing. The universe is happy. So the only thing that the universe cares about is real things happening inside the universe. And it doesn't matter, there is no, to the macro universe, there's no entanglement and no strange quantum variables that need some kind of detector, because the macro universe only works on things that really happen. So, for example, we have the famous atom that emits two photons going in opposite directions, one spin up and one spin down, and the strange interpretation of it is the universe bifurcates, not knowing which is spin up and which is spin down until it's measured somewhere. But according to my simple theory is, the universe doesn't care. It doesn't care that there's a spin up and spin down until something happens. So what happens is that one of the photons hits an atom and stops, and the atom absorbs it. Does it care if it's spin up or spin down? No. But it makes a change in the universe because the atom changed its atomic. The atom's electrons absorb the photon, so the other photon goes off quite happily, and it's absorbed somewhere else. And again, the universe has changed when it's absorbed, but there was no bifurcation of the being of the universe in this case. It just happens that the universe goes along merrily. There is a case where you have an experimenter who measures the photon, one of the photons, and measures its spin up. And he gets on the telephone and calls the other experimenter who has just measured the photon as spin down, and they jump up and down, and the universe counts that as a real thing. Likewise, in this case, if one of the photons drops into a black hole, the black hole cares not one whit about the spin of the electron. It doesn't change the energy level of the black hole whatever. And the other photon goes off to be absorbed by another atom somewhere in the universe. And the universe is happy that it's absorbed. Nothing that did change the universe. So I am kind of pleased with this, because the macro universe, there is only one of it, and it's and you can't. The quantum mechanics can't bifurcate the macro universe. The macro universe is perfectly happy, which brings then to the greater question is, what is gravity? And I, along with everybody else, don't have a clue. And I'm not an expert on Einstein's general theory. I wish I was, but I'm not. And I'm not really very good at mathematics. I'm ADD, so I lose attention when I'm faced with a big, difficult problem. But it appears, okay, we have the odd phenomenon of dark matter. And I think it's without a doubt that there is dark matter. We see it in the universe in our telescopes. It's measurable in the rotation of galaxies and other things. What we haven't been able to see is dark matter in our instruments. We haven't been able to detect a dark matter particle, which is really strange. Okay, so the macro universe thinks something's out there, and it does affect the universe. It's not quantum because of my hypothesis. It's a macro thing, it's gravity, but we haven't been able to see the particles. So I claim that this is a result of a fourth spatial dimension, at least a fourth or fifth spatial dimension. These are not tangled little string theory dimensions. These are real, big, fat, real dimensions. And all matter apparently has a little tiny extension into this fourth dimension. You know, every little atom, every little electron, every little thing has some fourth dimensional extension, and that forms a gravity. The dark matter is a matter that is firmly removed from our three dimensions into at some remove into the fourth dimension, much like we're like the two-dimensional creatures on a sheet of paper, and the higher dimensionality, the third dimension, has an effect on the sheet of paper, but we don't understand it. Let's say if we had two-dimensional beings on a sheet of paper, and we had three-dimensional beings standing outside the sheet of paper with a flashlight, the two-dimensional creatures would be greatly muddled and confused by this beam of light hitting their piece of paper from somewhere. So that's my hypothesis, is that this universe may have an infinite number of higher dimensions, and my hypothesis is that there's at least one which produces our effect of gravity. Well, for what it's worth, I'm going to post this on YouTube. Maybe somebody will watch it. I just had to do it. Thanks for watching.